Good morning, everyone. My name is Nico Metia. I'm the team lead for the CRISPS project, and I would welcome you to the fifth webinar facilitated by the Climate Resilient Sustainable Road Pavement Surfacings, or CRISPS in other words. CRISPS is a research project funded by the UK's Foreign, Commonwealth and Development Office and managed by IMC worldwide through the High Volume Transport Applied Research Programme. This 5-year research programme aims to increase access to transport services, more affordable trade routes, and safer, lower carbon transport in low-income countries. The 18-month CRISPS multidisciplinary research project aims to demonstrate the technical and economic suitability of 3 global best practice road surfacing technologies for the range of traffic and environmental conditions of high-volume roads that typically currently occur in low-income countries and those that are predicted to occur in the future. The CRISPS project includes partners from the University of Auckland, the International Roads Federation, University Putra Malaysia, then the University of Birmingham, as well as the Ethiopian Roads Authority, who will be leading, so the University of Birmingham and the Ethiopian Roads Authority will be leading this webinar, as you can see on the slide. So today's webinar explores new technology road surfacing constructability trials in Ethiopia. The webinar will provide brief background information about the material, which is the Fibromastic Asphalt, the modified Epoxy asphalt surfacings, and the modified Epoxy chipset surfacing, based on experience gleaned from the suppliers of the materials, industry experts, and a review of the literature. It will close with a presentation of the information about roads selected for the construction of both trial and control sections, followed by challenges faced by the project in the setting up stage and how they were overcome. Therefore, I'm delighted to be joined today by Dr. Gurmal Gattarora. Gurmal has been working in the geotechnical engineering industry and academia for 47 years. He has extensive international experience of materials testing, both in the laboratory and field, ground improvement, use of out-of-specification materials in construction, and the improvement of roads and railways, and extensive laboratory research. Gurmal has published over 140 peer-reviewed journal and conference papers. A substantial number of these are on materials and materials testing for roads and related topics. The webinar will be recorded for academic use. So without further delay, I will pass over to Gurmal. If you've got any questions, please use the Q&A session and there will be time for questions at the end. Over to you, Gurmal.
Good morning, everyone. I hope you can hear me clearly. I should actually say good morning, good afternoon, and good evening, wherever you are. Welcome to the webinar. So you've heard from our Professor Metier that the talk is going to be on new technology surfacing constructability trial, which is part of the CRISPS project. So without further ado, let me push on. Okay, screen's moving. Okay, so I'm going to give you a little bit of background about the work stream, i.e. where this work fits into the whole CRISPS project, and then give you a little bit of recap about fibromastic asphalt and epoxy modified surfacing materials. Both these areas were covered in our previous webinars. And then we will talk a little bit about climate in Ethiopia, site selection, development of specification methodology, and program. So where does this work fit into the CRISPS project? CRISPS has 4 key areas which need to be delivered. The first one is deterioration modelling. This is being undertaken in New Zealand, and there was a webinar on this. They, together with the University of Birmingham and Professor Ratna in Malaysia, will be also dealing with the life cycle modeling. At the university, we will also be dealing with some, we have been working on an anti-fraud framework, which is to do with the quality control of the materials used in the epoxy surfacings. And finally, we pull all these things together, and we are to undertake a constructability trial, which is the subject of this webinar. So the key aim of the work stream 4 is to demonstrate constructability of road surfacings using modified epoxy asphalt, fibromastic asphalt, and epoxy modified chip seal materials. So at the beginning of the project, we put together a sort of mind map which pulled together all the things we needed to do. So this looks like a bit of a web. So let me break it down a little further so you can see things clearly. So the first input into the project is actually literature review, and I should say inputs is data analysis. So we are looking at work that's already been done in Malaysia on FMAs, that's fibromastic asphalt. And then in terms of modified epoxy asphalt and modified epoxy pavement surfacings, we have input coming in from New Zealand through University of Auckland, where they have been doing extensive work on the subject. We are also looking at information that's in public domain through these through these studies in both Malaysia, New Zealand, and elsewhere in the world, and any experience Ethiopia has on putting surfacing materials down and elsewhere. So all that literature review goes into feeding the constructability trial. So the next key area we need to address is selecting the site. So how do we do this? And this is where input from Ethiopia is very, very important, because the trials are being constructed there. We need to use their plant equipment, labor, and other resources. So in terms of selecting the trials, we needed input in terms of what the road condition, what the roads are in Ethiopia, what the climate regimes are, how do they monitor condition of the roads, what sort of maintenance takes place, and what the construction procedures are. So we then pulled all this information together with the other information from Ethiopia and around the world, which we gleaned from other studies, to put together a selection criteria, which we will talk about. And all this information about modes of failure, drainage, wearing course, construction, maintenance, proximity of resources went into putting together a selection criteria. We then looked at other areas such as modified epoxy chip seal and epoxy asphalt as part of the new surfacings which we want to put down on roads in Ethiopia. And we needed a whole lot of information about design, construction, health and safety. All these needed to be addressed for the 3 technologies we are pulling together to trial. Last but not the least, we needed to consider monitoring. We need to know about how the roads which we're going to select or are selecting have been monitored, and what sort of monitoring will take place after the roads have been constructed. Okay, just a recap on previous trials, and so I'm just going to go through now the previous webinars. I'm going to run through fibromastic asphalt and epoxy modified surfacing by way of a recap. So this is fibromastic asphalt. Here we are using cellulose fibers from the oil plant, and this is a plant here, the oil palm tree. Once the oil has been extracted, we are left with this vascular bunch, and this processed into fibers such as this. So we're going from there to these pallets, which you can see here. So why are they being used, and in fact, how big are they? Let me talk about how big they are, these fibers. Well, we put a little guide here in terms of what you can see. The human eye can see up to about 40, something which is about 40 to 50 micron in size. Human hair is about 70, give or take 20 micron in diameter. So the oil palm fiber, you can see it's around the anywhere between about 10 to 30 odd micron. And there's a lot contained in these pellets. And this is extract from webinar 2, which was specifically on fibromastic asphalt. And you can see the sort of specification that's being used in Ethiopia. So the properties are something like moisture content 5% or less. It's got to be quite a dry material for it to be used. And for road construction, they use material which has the pellets have 80 to 90% fiber in it. And they've simply added this to their surfacing, and they've monitored its performance, and you can see that it's given stability improvements over a conventional gap graded material of around 125%, and the resilient modulus durability increases by about 90%. All in all, it's proven to be quite a good material, and it's being used on some surfaces in Malaysia. Hence, it's been brought into this project. Now, this is relatively new technology, although they have been working on this for 20 odd years in different forms. But actually putting it in the roads is a very recent thing. So let's move on to epoxy materials. So why have they've been using this in Australia? In New Zealand. So this is an extract of a couple of slides from webinar 3. They have found that when they've used epoxy asphalt surfacings, it gives them improvement in terms of resistance to water ingress in the pavement. And also it's resistant to higher temperatures. Now, we need to remember that this material was developed for airfield applications in airfields some 40 years ago, and I'll say more about this later. Let me just do a recap on this first, on why it's being used. And they have actually found improvement in overall performance, which you can see here. Now, the slides for both webinar 2 and 3 are available on the internet, so I expect you can read more about this later on. Carrying on with webinar 3, they're looking at the deterioration model of these pavement surfacing, as we showed you a little earlier. And so they have been using these surfaces in New Zealand for a few years now. So they have a lot of lab data available, they have field trials available, and this is all being fed into an HBM4 type of study, which will be used to look at deterioration modeling, and it will input it to whole life cycle analysis in terms of costs. So let me just extract a slide which gives us a few words about the origins of this material. It was developed in the 60s for airfields. It was to stop asphalt melting under the effect of jet engines. And it was quite successful. And then after that, it was used as a bridge deck surfacing, and it has been proved very successful, and in some cases lasted over 40 years without any issues. And hence, people are beginning to look at it in terms of applications for roads. So epoxy material is a two-part mix of two components. Part A is an epoxy resin formed from epochlorhydrin and bisophenol. And part B is a fatty acid, which is added to 70-grade bitumen. So for this project, we are using part A, which is common to both epoxy surfacing material and, asphalt surfacing and the chipset material. There is, however, variation in part B. And for the surfacing, asphalt surfacing, we are using a mix which contains of 85.4% of part B and 14.6% part A. For the chip seal, there's a different concoction of part B, and the proportions are slightly different. Okay, so why the attraction? Well, the work done in Australia, as demonstrated by David Alabastra in webinar 3, through his work with OECD on long life surfacing materials for pavements, showed that it was stiffer at service temperature with greater load spreading ability, more resistant to rutting, and low temperature cracking initiation, which will help with durability clearly. Better surface abrasion from tire action and even after oxidation, so it helps again with durability. It's more resistant to fatigue cracking, less susceptible to water-induced damage, and resistant to oxidation. Essentially, these items are covered in that statement there. So that's the key attraction. So what have they been doing under the OECD work and later? So here are some more slides showing that. They've done a lot of lab work. They've done large-scale trials, small-scale trials where they've done work manually on localized small areas, which I'll mention in a short time. And then they have modified their asphalt batching plants by adding another facility for adding part A into the mix. And here is just one of the slides showing the improvement. This is about loss of material, and these are conventional materials. One of them is with SBS. You can see there is quite a bit of loss here compared to materials with even 25% epoxy. Shows you quite a lot of improvement in performance. Okay, so here is a small scale work and the large scale work. So let me talk about the chip seal work they've done on a small scale. And they've manually mixed the materials in areas of around 10 square meters. So they manually sprayed the two components and put the chip seals on and then trafficked them. There's more reported on this in the webinar 3. And it showed to be quite successful. And then they moved to the larger surfacing work where there was impingement. There was a second spray bar added to the conventional sprayer. So so the two components, part B and part A, impinge each other's outlets. So the two components mix just before they hit the road surface, and the chips are then spread. And this also proved to be quite successful, and they've been using it successfully in New Zealand. Okay, in terms of overall performance, you can see here, this is some data from over 10 years worth of work, again from New Zealand, and you can see there's much loss of material with conventional bitumens, and these two are with epoxy materials. And you can see whatever type of epoxy we're using here, it's showing much better improvement compared to conventional. So let's move on to work in Ethiopia. So the first call was to put together a site selection criteria. And this is a 4 or 5 page document. And this is just an extract for me to show you the site selection information that was required to select the site. So here we wanted to know about local geology materials that were used in construction, planned to be used according to the standards and what was there. So we needed to know things like CBR, moisture content, strength, all the usual things. We also needed to know about traffic loading, what sort of maintenance procedures are in place, how often the surfaces are maintained, and so on. Key here was also drainage condition. We needed to know how good the drainage was and how that was maintained. And finally, we needed to know about road condition and how that information was monitored and how the data was dealt with. And there are a few other things about collecting weather data, local hazards, earthquakes, and so on, which were quite pertinent. So based on this, we selected two sides. The first one is Mojo Ejire Road, which is a B51 road, only a few kilometers from Ethiopia. In that extract, we have Ethiopia here. This is Mojo. In some maps, you'll find this spelled as M-O-J-O. Correctly, it should be M-O-D-J-O. Ejire is around here, and we are building a chip seal surface along that road, and I'll say more about that later. And the second trial surface is, oops, Daisy, let me go back to stage. Here we go. This is A10 trunk road, and it's connecting Awash with Mezo, which is a little town here. And this is a road, as you can just about make out from here, connecting Addis Ababa and central Ethiopia to Djibouti. So there's quite a bit of traffic running along this road. It's one of the key link roads to Djibouti. And if you check on Google Earth, you'll see quite heavy traffic along this road, heavy in terms of size of trucks and so on. Okay, so let's tell you more about this. So we initially did a condition survey on the road, and these are just slides showing you the road. And you can see its surface. This is Mojo Ejire Road. This has a shoulder width of about 1.8 meters. The carriageway width is around 3.5 meters each. And you can see it's the surface is reasonably good. Some more slides, and you can see some leaking of bitumen here, and some more extracts from the surface. This is measuring rutting along the road surface. Okay, this is the Awash Mezo Road. Clearly, we picked a very nice, quiet day when we were doing this condition survey. And here the width is about 1.5 meters, but in sections we have selected, in fact, in most of the road, the shoulder is only a gravel surface, but it's 7 meters, and the structure is more robust. It's a trunk road carrying heavy traffic along. And as you can see here, this condition is quite good. Where we needed some information, we have undertaken field work, so you can see some trial bits being undertaken and some coring to measure thickness in the road. Now I'll say more about why we needed to do this work. And okay, so details. We narrowed the list down to about 3 or 4 road sections with up to 4 sections for the trials on each, and then we honed in on the roads I mentioned. So let me just move this out of the way. In the this is the information that was available, and here after our surveys we've selected the sections. So you can see here we've chosen 200-meter sections. One of them will be for the trial construction, and the second one is the surface. Now I should mention that both these roads are part of a Ethiopian Roads Authority surfacing contract. So they are already going to be surfaced, and sections of the road will be selected for our trial. So that's the section. So we've now honed in on finding out what the condition of the road is, and you see the information. Overall, it's looking good. No maintenance undertaken except routine. And the dark, expensive clay subsoil is present, and we have the geological description of materials here and some additional material information here. And we've extracted general information about rainfall, thicknesses of base courses, and so on. Now, this road was opened in 2012, so there's a lot of information available about the pavement structure and layout of the road. As opposed to the Awash Mezo road segment, which was constructed and opened to traffic in 2013, or last redone in 2003, I should say. And so there is little information available about certain aspects. So hence these red font here, because this information was missing when we first did the tentative selection of the site. Subsequent to that, we have done another site visit, undertaken laboratory tests, and we have ascertained all this information. This bit about annual rainfall, we have information about the rainfall. I just haven't updated my chart here, and I'll talk about the information in a second. So there is routine maintenance, site investigation was undertaken to get the information and so on. And here we see the information about lane thickness. It's a 2-lane road. The shoulders are unpaved and the terrain is relatively flat all the way across. So test results, I've just extracted here some specimen data to show you the sort of things we have measured along the road. So properties of materials that are being used in roads for both the Meso and the Awash, Meso Road and the Mojo Ejire Road. And you can see here a different spelling is being used in this file. Okay, some more data about the Awash Meso. This is the road section. If you remember, I mentioned that there was little information available about properties and some other aspects of the road. So some specimen lab data is here. There's a lot more about particle size distribution, about the properties of subgrade soils and so on. Okay, so let's move on swiftly to what we are planning to do. So for asphalt surfacing, that's FMA and MEAS, which is modified epoxy asphalt surfacing, we are planning to put a tack coat and then put the additional surfacing on top of the road. Now, the planned work for this road section for the new contract era having place, they are planning to exactly the same. So this will be a conventional asphalt surfacing for most of the road. For our sections, we'll use FMA and MEAS. And this is the standard tack coat which they're going to apply. So we'll be comparing this with the standard material they will put down as part of their contract. And I should just go back. In terms of chip seal, we are going to do the same. And instead of putting the asphalt surfacing, all there we're going to do is put a chip sealed surface, which is also planned for the Mojo Ejire Road, and it'll be comparing almost like for like. The only difference will be material. Okay, so FMA. There was a webinar on FMA, which we talked about. We have prepared draft procedures for the plant construction modifications. There are some areas which need confirming, and I'll talk about that in a second when we go through here. And the current position is FMA material is in road research laboratories. The key issue we are discussing with ERA at the moment is modifications required to plant. In simple terms, all we need to do is add the fiber to the batching plant. All the other procedures are essentially the same. We're using the bitumen as per their existing standard. We're not changing any of that. The aggregate, nothing will change. All we're doing is adding the FMA. And so we've drawn up the procedure to this, and we have specification, particle size distribution, everything is there. Now, still carrying on with the FMA. So this is the easiest material to put down as we see it, because very little modification is required, very little new learning is required for the team in Ethiopia, for the contractors team and the construction team. We simply need to make sure that the plant is going to operate properly and the temperatures can be controlled to within the required parameters. And we don't see an issue there, but we still need that confirmation from Ethiopia. Now, let me just add, as it is part of the existing contract work Ethiopia is planning to do in any case, they are going to use a plant, which we will talk about in a minute, and the plant experts need to make input into the project. And so we are communicating with them at this moment to finalize that bit. Okay, so modified epoxy asphalt surfacings. We've opted for denser asphalt. Most of the work around the world has been done on open graded asphalt surfacing. We're opting for this because there is no experience in Ethiopia of using open graded asphalt. Remember, this is constructability trial. Once we have shown or demonstrated that we can use the technique for putting the road surfaces down, then there will be further work undertaken to move on to open graded, which will be more cost effective. But for the purposes of the trial, and to reduce the amount of learning by the operators and the team in Ethiopia, we need to make as few changes to the procedures as possible, particularly as this is part of an ongoing contract and we don't want any mistakes. So notes and procedures have all been prepared, which are here. Again, as with FMA, there is more, we need some more information about the plant in particular, and that's being sought out urgently at this stage. Okay, so the current position in terms of work done on this aspect is that the roads have been selected. As you know, the materials have reached Ethiopia. They are beginning to undertake laboratory tests to get familiar with epoxy materials and FMA, and we are talking to them about the modification to the plant. Now, we plan to use our existing plant, and there will be only a few modifications required. And as before, we need to make sure that we can actually use a plant with as few modifications as possible. Okay, so on the right-hand side, we have information about the road surfacing, what needs to be done, about batching the asphalt material. You can see there's a whole lot of material we have put together on this. Okay, and let's move on to the next bit. So the plant they require is a mobile batching plant, which needs to be brought towards to the site which they're going to use for surfacing the whole of the Awash Mesa road surface. And this plant has a capability of 60 tons per hour. Maximum batch is going to be batch capacity is about 700 kilos. Now the challenge we face here is adding part B into the plant. So the part A. Part B will go through the conventional routine where we put the bitumen into the mix, and then part A has to be inserted into the stream as a through a premix connection into the injectors for part B or bitumen, or it'll be added separately. And that's the discussion that's going on at the moment. And we are waiting for the plant experts. There are people available in Ethiopia, and we're expecting an expert from China to arrive there at any time. And once that's sorted, then it's all systems go. The rest of the procedure is pretty much conventional. Other key thing we need to address here is the temperature. Plant is capable of around 130 to 160 degrees temperature control. Now, part A of our mix is at room temperature. It's a viscous material, a little bit like treacle. We need to warm it to around 45 degrees to make it pumpable. Part B is essentially bitumen with additives in it, and that's quite solid at room temperature, and it needs to be heated to about 110 degrees to make it pumpable. And we need to make sure that we can achieve those sort of controls in here with some accuracy, because one of the key things is to make sure that the heating of the two components of the materials are uniform, and when they are added to the mixing plant into the aggregate, that unit is also heating the material uniformly. If there are hotspots in here, we can have a homopolymerization reaction taking place, and the material will simply go hard, and it'll, in other words, it'll start to set. And those are the sort of fine details we're trying to get to grips with at the moment. Okay, in terms of chip seals, we've had discussions with experts in the area, John Bowes from Kenco and Jeff Waters from New Zealand. I should just add at this stage, in putting together the specification and procedures for the asphalt, John Bowes and Jeff Waters have also been key to preparing the documents. We've had a lot of very, very useful input from them. John Bowes is his company is supplying the asphalt, the epoxy materials, and Jeff Waters is a consultant at the moment working in Ethiopia. He specializes in road surfacing, and both these gentlemen have been key to the work we are planning to undertake in Ethiopia. The other name I should mention who's made significant input is David Alabaster from New Zealand Roads Authority. He has also made input into the work because he's been key in, together with Jeff Waters, in application of both the asphalt surfacing and chip seal material in New Zealand. Okay, so draft notes are prepared. Again, there are a few issues that need to be addressed. They relate particularly to the spraying aspect of chip sealing. We have the material in Ethiopia. It has arrived from, in fact, the material has actually arrived in ERA. It only arrived a week ago. And they are now beginning to do some work in the laboratories to get to grips with how this material behaves, and then we're away. So discussions are centered around how we feed the second component into the spray bar, an image I showed you earlier. And there are many discussions, and I'll go through that. So this is what the specification looks like, all the procedures about how we're going to put the material down, the sort of chip seals we're going to adopt, chip materials we're going to adopt, how the roads are going to be open, what the desirable layout of the plant is, and so on. Okay, so let me show you what the desirable layout is. So we have the standard spray a unit here. We want to add another spray bar here. Part A will be spraying from the jet, which drops the spray vertically, and part B is angled, so they both impinge into each other just above the road surface, and the material then comes in here. The key issue is about the second tank. How do we add this? And because it's not just a tank, adding the tank, we also need to add the second spray control unit, pump, monitoring unit, and so on. So we put the material down in exactly the right component. There is a little bit of slack in the mixing the two, but we want to make sure we hit the target and we don't go too far out of the specification in terms of the ratios in which the materials are mixed. So one option was to add another tank as is this unit here. The second one was to tow the material behind this. So here are the tow the second smaller tank behind the first one, or tow it separately. So the first option we are considering is where we put the second smaller unit behind, we tow that from the spray tank, which means both are traveling at the same speed. And ERA has this smaller unit. It's a case of how we attach it to this. So that simply tows behind it. The issue here is what happens to the epoxy material sprayed from part B sprayed material when part A runs on it, because it's going to create two areas of weakness along the tire tracks of the trailer. So we considered this option as well, where it's told in part A trailer is running parallel to part B. And the favored option is this, where part A trailer is running ahead of part B. So whatever comes out of the spray bar, nothing runs on it except chip seal surfacing. And once that's been put on, we can open the roads to traffic. So this is what we are running with. ERA is going to attach a second spray bar to their existing spray truck, and so there should be no issues there. The key issue we have to address is calibration of flow rates, which is standard procedure for ERA and others who use chip seal spraying. So that should be no issue there, but we still need to make sure everything is done and the quality control measures are compromised in any way. So that's where we are at the moment. So what are these sites? So we indicated on the map earlier approximately where they were. So where are they in terms of climatic zones? This is a extract from Bertanu's work on water resources in Ethiopia, and he's indicated classic traditional climate zones, and there are 5 of them, and our road sits in the Kola zone. So this is the Kola zone, is described as a warm semi-arid. The key things for us are rainfall and length of the period, growing period. Let's not worry about that. And the other one is the temperature. Our sites have a temperature slightly outside this, where we go as high as 30 odd degrees, so you'll see. So we've extracted data from the region, and this is the rainfall pattern. So the dashed lines are the range, and the line in the middle is the mean. So you can see this is the temperature. It's relatively constant. We wish we had this sort of temperatures in the UK, at least in the summer, never mind the other parts of the year. But you can see the temperature is somewhere, maximum is around 25 to 30, minimum hovers around the 10 to 12, I should say 8 to 12. Okay, so the rainfall, which is quite important for us. And you can see rainfall, this data incidentally is a 7-year average of the data. So the 7-year average for January is the solid dotted line. For us, we felt the other important bit of information was the number of rainy days, which is the dashed line here. And you can see from July to end of September, we have a rainy season and a lot of rainfall days per month here. And therefore, it's going to be difficult to put any surfacings. And indeed, in Ethiopia, they don't do any surfacing work during this period. So all the works will stop. So here we have variation in rainfall in percentages and in actual numbers. And you can see the variation is anywhere up to 40%. Sorry, up to 40 millimeters. You can see here. 10 to 15% in terms of rainfall quantity. Okay, so you can see there are times, there are some years where there is less rain. So we hope that we might get that sort of scenario where we hope for that, but we'll see what happens. Now, in terms of the program, we've scheduled our work to fit in with this rainfall season, and that's what we're going to talk about next. This is a planned program of the work. The contract ends in December. This is the rainfall season, and we were initially planning to finish the work in about May, but the project has been delayed. And one of the key reasons for the delay was actually getting materials into Ethiopia. There was a lot of red tape, but it was red tape was running in parallel with with COVID, because it was very difficult to ship materials into Ethiopia during the COVID period. However, we have the materials in Ethiopia now, and everything we plan to do after that has to be done now before the project ends. So the epoxies with high red hatching are the key deliverables, and we have modifications to plant for all the three identified here. And during the rainy season, when we are not able to go in the field, we will be undertaking laboratory testing, modifying the plant, because the plant will be modified and reset up. Certainly for the epoxy materials will be reset up during the season. And once it's in place, we can do the construction. In terms of the chip seal material, we may be able to bring this forward a little bit. In fact, we may be able to bring all this forward depending on when the rains stop. There's a plus-minus 2-week limit on this. So we're hoping we can actually start construction in the middle of September rather than push it here. There is some slack here in terms of pulling the program together faster. And we may be able to move some of these activities further up as the laboratory staff start getting experience of using epoxy materials. We can pull this up. FMA work is pretty much in hand. That won't be very much needed. We simply needed the materials in Ethiopia to be able to put things together. So all in all, the work real work is now beginning in Ethiopia, and we hope to hit the target with the construction. We are working on the basis that there is no slack in the system at the moment, and everybody's doing their utmost to make sure that things are done and we make the delivery for the project. Okay, with that, I need to stop. Before I do that, I need to acknowledge the input from John Bores, Jeff Waters, and David Alabaster, who have been key in helping us put together the methodology and other aspects of the field trial. They're also helping us with health and safety work. We see that as key to the project. And of course, they're also helping us with the quality control work that needs to be done in parallel with the other aspects which we've discussed. So with that, I will stop. Thank you very much for listening.
Thank you very much, Gurmo, for a really exciting presentation. We've got just about time for a few questions. Again, if you put your question in the Q&A, please, then we can ask Gurmo the question. So I've got one question for you, Gurmo, which says, it's a great job, a nice presentation. And the question is, in your literature and of field observation in Ethiopia, do you consider the quality control of the construction most important / critical? Experience on the previous trial section on otter seal, sand seal, and various LVR surfacing materials who have been under monitoring for a couple of years, some years ago, indicate that construction QC and consistency are quite important to obtain meaningful performance measures.
I think the short answer to that is yes. We consider it to be imperative. The two components of the epoxy materials, A and B, have some slack in terms of their ratios in which we can mix them, but we need to get the optimum performance from our materials. What I should have mentioned at the beginning is that we have a couple of PhD students working on the project. So they started their PhDs before this work, and this project forms a small part of their work. And so they are bringing rigor to it. They are based in Ethiopia, so that we are ensuring that there will be rigor in terms of the work that's being done. We have been holding regular meetings with colleagues in Ethiopia, and we have impressed upon them the need for quality control. And there will be procedures in place to monitor all sorts of things like temperature input of materials into the pug mill, temperature of material in pug mill, temperatures of material during haulage, how it's being placed, density, and so on. All the quality controls are written into our specifications, and they will be refined a little bit more once we know about capability of the plant. So yes, we consider it to be absolutely imperative. The other reason for this, I should just add, is that we are treating, ERA is making a very large input into the project, and it's running into tens of thousands of dollars in terms of their input. And they are looking at it as something that will provide them with base information for possible use of these technologies for their roads in future. And so we'll be monitoring and ERA will be monitoring these roads for a period well beyond the end of the project. And they will be then taking that information, evaluating it, and if everything works out together with whole life costing, the aim is to build it into their standards. So certain roads which receive a lot of traffic and are prone to receiving high maintenance may be suitable for such applications. So we think for a couple of reasons, quality control is absolutely essential. Thank you.
Thanks, Gurmal. Just thinking of the time, so we've had quite a few questions coming in, so maybe we have to keep the answers a bit shorter. So I've got one question. Is there any chance of bringing the FMA trials forward before the rainy season, as it seems reasonably advanced?
Yes, it all depends on the plant. At the moment, ERA are in the process of moving the plant to the site where they will do the resurfacing work as part of the contract. If they can do it, then the intention is to bring it forward. Yes.
Okay. So another question about the timing is, it seems that the chip seal double spray bar mixing is a tricky key problem. Is it possible to obtain one from New Zealand complete with control servo valves and monitoring kit, as this is critical?
We haven't considered that, but it's a very good suggestion. We can consider that. Well, I should just add that ERA are in the process of modifying their existing plan for doing that, but I appreciate the suggestion and we'll follow it up. Thank you for that.
I've got one question. How many palm trees per cubic meter of FMA?
Very good question. I'll just say pass.
Okay.
Can I just add that this is a material which is made from waste from palm trees. So we're not putting any more plantations down. We're simply utilizing what's there at the moment.
Thank you. A couple more questions. Can the epoxy materials be produced locally in Ethiopia at a later stage?
I don't know the answer to that. All I can tell you at the moment is we're trying to get universities in Ethiopia involved. And the starting point is the anti-fraud system. We're trying to get University of Addis Ababa involved in doing some local testing of materials. And I think with time, once this material is accepted, then it's a possibility.
One other question. How can an interested civil engineer physically participate in the training for adaptability? It's someone from Uganda.
The intention is to hold some sort of workshop towards the end of this, and I think, Nicole, you're probably better placed to answer this. And I think that would be a good starting point. Also, through these webinars, you understand you will get to learn what's being planned and what's being undertaken in Ethiopia. And no doubt there'll be further work on seminars, workshops after the material has been put down through Ethiopian Roads Authority. And so there'll be plenty of opportunities to get to learn about this.
Absolutely, I can only add to that. That's definitely the plan, that I think ERA is going to also do something more local. That was always the plan, and that's what we want to do probably once we have completed the constructability trials, so we have a better understanding. One more question. How can we control the quality of the fiber and also the epoxy asphalt?
Okay, at the moment, epoxy asphalt is coming from from California in the USA. So we are assured of the quality. When they're mixing, if we need to dilute any materials, then they'll be using local epoxy materials, which have ERA has rigorous quality control on the local bitumens. In terms of fibers, at the moment, we are using oil palm fiber, which is being processed in Malaysia. And the longer term intention is that ERA will pick this technology up and start to use local waste fibers in asphalt using the same type of technology as FMA. Other people have used fibers in asphalt, so there should be nothing strange about that. But for the project, we are importing the fiber from Malaysia, and that in a way has caused a few delays. We have undertaken some preliminary literature review on fibers available in Malaysia. That study showed that there was nothing there we could use as things stand. But the know-how developed with this project will be useful in doing that. And that also brings in our links we're developing with the university there, because the ERA University of Addis Ababa, perhaps other universities, will hopefully be enthused to carry on working in this innovative area to develop new technologies or new materials.
Yeah, and for the epoxy, I should also say that if you look at the previous webinar where we talked about the quality control, quality assurance of the epoxy material and talked about FTIR and FNAA analysis. So we are planning to conduct FTIR analysis in Ethiopia where we basically have developed a fingerprint with the material here when we did the tests in the UK, and we are trying to replicate some of the tests to ensure the quality. We have no outstanding questions, and I also realized that the time is up with being dead on 8 o'clock UK time now. So I would like to extend a big thank you to our panelists and to our audience for their active participation. And of course, a big thank you to Gurmal for a fantastic presentation. This has truly been a fascinating discussion, and one that I think warrants further development. And we've taken away some ideas of things to look into in the future. I would also like to thank our funders, the FCDO and the HVT managers, IMC Worldwide, for providing support to projects that address climate change impact on transport systems, and the IRF for facilitating this webinar. Whilst the subjects we have discussed today are academically fascinating, they also have real-world impact. The CRISPS team will be organising another webinar in early to mid-summer 2022. So please look out for more announcements. We will continue to share our experience. Thanks ever so much, as I said, to the audience, especially to Gurmal, and also to Augusta and her team for organising the webinar, and hopefully see you at our next one. Thank you very much. Bye.
Thank you all. Bye.